All right, in this video, I might talk a little bit about the inverse trig functions, okay? So I'm going to be looking at, sine inverse, cosine inverse, and tan inverse, okay? And so I want us to think a little bit about that before we start using it to work some problems, okay? So let me get a blank Word document here. All right, so we've had to use sine inverse, cosine inverse, tangent inverse. We've had to use those before. All right, when you were solving a triangle, for instance, let me just kind of remind you. So say you had a triangle and you're trying to figure out what this angle is, and maybe they gave you one side, maybe they gave you that, and maybe they gave you the hypotenuse, something like that. We wound up having to use sine inverse in order to figure out the measure of the angle, okay? That's actually the inverse sine function, okay? So what you wound up thinking was, you started out by thinking, well, the sine of the angle would be opposite over hypotenuse. So what I need to do is do the inverse sine of 2 over 7 to get my angle, okay? And so you wound up using that already, and you came to your calculator and you hit second sine to get the inverse sine. You did 2 divided by 7, and you wound up getting, let me change my mode. I was in radian mode. I'm going to change it to degree for just a minute. So you wound up doing the inverse sine of 2 divided by 7, and you wound up getting, like in this case, it would turn out to be about 16.6 degrees. And I was in degree mode when I did that because I was working on a right triangle type problem. All right, so you've had to do that before. And so what I want you to kind of think about is, when we had an angle, if we applied, say, sine to that angle, we could get a value. So we wound up getting a value of the sine of the angle, okay? Well, if we wind up taking the value and using it as the input to the inverse sine function, that was supposed to give us the angle back again, okay? So with sine, here is the angle in your mind, and this is the value of the sine of that angle. Right? Well, what happens with sine inverse is, what goes here is the value of the sine of the angle, and what you get back out, supposedly, is the angle, or that's the way to kind of think about it. Okay. All right, so when you have something like sine inverse of x, okay, when you're thinking about that, what is sine inverse of x? Okay, think what is the angle whose sine is that value? Okay. Right? Now here's the problem. Here's the tricky part. All right, think about the sine function. Remember what it looks like? Kind of fluctuates. Okay, it goes up and down and up and down and up and down. Okay. So the problem is, if we think about it, if we limit ourselves to thinking about sine inverse this way, let's say the x value is a half. Okay. Remember how sine goes as high as 1? This would be up at 1. This would be at -1. Okay. Then if you were looking for the angle whose sine was 1/2, trying to cut halfway there, there'd be a lot of answers. Do you see that? Here's a whole bunch of spots that have a sine of 1/2. You see that? And so I would have angles whose sine would be 1/2. I would have a whole bunch of them. Do you see that? Okay. And so sine inverse is supposed to be a function. Okay? So that means that when I get an answer to the sine inverse of x, when I do it on my calculator, for instance, it doesn't give me a whole bunch of angles back. It gives me one angle. Okay? It gives me one angle. And then, we had some issues with that, if you remember, when we got to using the law of cosines and the law of sines. We had to worry about whether the calculator was giving us the angle we needed to. Okay, so right now we're just kind of talking through some of the issues, and then we'll clarify. So what you want to think about is sine inverse of x. You want to think that what that is doing is it's supposed to be giving you the angle whose sine is x. Okay, the problem with only thinking of it that way is there's a whole bunch of angles who might have a sine that turns out to be that value, because the sine function is periodic and it keeps on repeating. And so you're going to hit the value that you have here a whole bunch of times. And so you'd have a whole bunch of angles. But if we want this inverse sine to be a function, then it's only going to give us one answer back. And that's what the answer that our calculator gives us. So like when we did sine inverse of 2/7, it gave us just 16.6 degrees back. Well, that was perfectly okay when we were working in the context of, a simple acute triangle. But do you remember those problems where you wound up having to think about, we had a situation like this. Remember those pictures where we were dealing with triangles where you could have two possible situations? You could have one triangle that fit the given information, or you could have a second one, okay, that fit the given information, where one of them had an acute angle and the other one had an obtuse. Our calculator would give us back the acute angle, and then we had to think about, okay, the calculator gives me the acute angle over here, and then we had to know, yes, but here's another angle that could be an angle in a triangle that would have the same sine value as the original one, because they have the same vertical height, and sine is related to that vertical height. Okay, so you remember that issue? The calculator only gives you one angle back. It gives you the acute angle back, okay? But sometimes you had to come over here and find the obtuse angle, okay, that would have had that same sine value, okay? So here's what we have to do. What we have to do is we have to go back to our graph of sine, and we're going to go to the graph we made earlier, and we have to restrict the domain of the sine function to be just one, to be a graph that when we do the inverse of it, we will have a function. Okay, so we have to restrict the domain so that when we do the inverse of the sine function with the restricted domain, we'll have the inverse sine function, and it'll be a function, okay? All right, so let me go back and let's go look for a moment at the original sine graph we did. Okay, there it is. All right, so there it was. All right, now, what it takes to have an inverse that's a function is something you actually learn in pre-calculus. Not only does each x have to have only one y, okay, each y has to have only one x. And so the fact that this graph doesn't pass the horizontal line test, like I showed you earlier, if we were looking for sine inverse of 1/2, and we thought about it using a sine graph, we can see how we would hit the sine graph in a whole bunch of spots. And so we'd have a whole bunch of angles whose sine is 1/2. So if we're trying to do inverse sine and we want it to report back exactly one angle, only one answer like the calculator does, what the calculator is doing is it's restricting your sine graph. And this is part of your job. This is number 9. On the graphs that you created earlier, highlight the portion of the sine, cosine, and tangent functions that are used to create the inverses for sine, cosine, and tangent. So what we're going to do is highlight a portion of the graph, okay? Just that portion. If we restrict ourselves to just that portion right there, that covers all the possible outputs to the sine function, okay? And so you see now, if I were to draw a horizontal line, it would only hit that yellow portion in one spot. It would hit it right here, okay? And that would be the angle that the calculator would give us, okay? And then if I wanted to find sine inverse of -1/2, and I thought about that line here at -1/2, it would have hit the original sine function in a lot of spots. But since I restricted my domain now to just this yellow portion, that means it's only going to be -1/2 when I'm at this angle, and I just need to find out what that angle is. And I'd only get one angle as my answer. So what you see in yellow is what you want to do for number 9. That's how I'm going to restrict the domain of the sine function. I'm going to restrict it to be from -π/2 to π/2. Okay? Let's look at what it would take on cosine. So what it is we want to try to make it where not only does a vertical line cross the graph in just one spot, that's what makes it a function. We want to make sure a horizontal line would only cross the graph in one spot. Okay, that helps, that makes it so where the inverse cosine function would be a function. So when we do the inverse cosine of that restricted portion, we only have one angle reported back. So you see how if I highlighted this region, how a horizontal line would cross what you see in yellow in just one spot? So see, from 0 to pi would be how I want to restrict the original cosine graph so that the inverse cosine would turn out to be a function. Okay. All right, let's look at tangent. There we are. All right, and then for tangent, if I just take one piece of this, and notice we're taking those pieces that are right around the origin. We could have taken a different piece, but this is what kind of the agreement we're making, is we're going to take this piece of the tangent graph, so just ignoring all the other ones. If we draw the graph of the inverse of that piece, we'd have something that would also be a function, okay? So that one goes from -π/2 to π/2. Okay, so we do -π/2 to π/2 for tangent. For cosine, we did the same, -π/2 to π/2. Okay. For sine, we did -π/2 to π/2. Trying to get to cosine. And for cosine, it was from 0 to pi. All right, now I want you to look at one more thing and then we'll go to the chart and we'll fill it in. All right. So look at the region that I highlighted down here in yellow and think about where that is on the unit circle. Okay. I'm going to highlight that on the unit circle. I think it really helps to think about the unit circle when you're doing these. Okay. So if you do sine inverse of some value, of some number, so that means you're plugging in something that's coming from this side of your sine. If you do sine inverse of some number that would have been over here in the y side of your sine, what's going to happen on your calculator is restricted. It has the same agreement. It is going to give you an angle somewhere between negative pi over 2, that would be here, and pi over 2, which would be there. Okay? So it'd be in the first and the fourth quadrants. Okay? All right, let me move to cosine. All right, so with cosine, if I did on my calculator cosine inverse of some number, the number would be like in the y area, okay, on your cosine graph. So if I did cosine inverse of some number that would have been a number that would have shown up on the y side of the cosine graph, my calculator is going to give me one thing back. In my mind, I think of it like an angle. It's going to give me one thing back, one angle, and that angle is going to be somewhere between 0 and pi. All right, so it's good to think about where that would be on the unit circle. That connection between the graphs and the unit circle is really helpful. So that means it would be from there to there. It'd be in the first or the second quadrants. Okay, this becomes important when we try to work problems in a minute. All right, and then let's go to tangent. And what we notice on tangent is we're also restricting ourselves to negative pi over 2 to pi over 2 for the domain of the tangent function. So what that means is that when you're given back an angle, when you use your calculator and you do tan inverse of some number, you're given back basically an angle that's between negative pi over 2 and pi over 2. So that means here to here again, okay? All right, so let's go back to the learning guide. Down a little further where we're actually compiling this information. All right, so what we talked about is the inverse sine, inverse cosine, inverse tangent, those functions. In order for those to be functions, we have to restrict the domain of sine, cosine, and tangent so that the inverse will turn out to be a function, okay? And the domain of the sine, cosine, and tangent, you know, that's where the angle would have gone. That turns out to be the answer when you do sine inverse, cosine inverse, and tangent inverse. The answer to those is the angle, okay? All right, so what you want to think about is, well, where is the angle coming from when I do the sine inverse, okay? So remember, sine inverse, the range, what the calculator will give you back is anything from pi over 2, negative pi over 2 to pi over 2, including those, okay? All right, and when you think about that, that means quadrant 1 and quadrant 4, all right? I think it helps to kind of look at and remember that picture for sine inverse. All right, for cosine, it gives you something from 0 to pi, including those. So that's in quadrants 1 and 2, isn't it? Now with tangent, it's also negative pi over 2 to pi over 2. But remember, let me flip back here for a second. But you see how at negative pi over 2 and pi over 2, how we have vertical asymptotes? So when I write this, I'm not going to put brackets. I'm going to put parentheses on those. But I am still thinking quadrant 1 and quadrant 4, okay? That those are the angle values that the calculator is going to give me. And so for tangent, it's also giving me angles that are in the first or the fourth quadrant, okay? All right, so I'm going to stop the video here. Our next video is going to actually work through some problems where understanding that is necessary. So I'm going to be using this section 5.7 worksheet. So you want to go find that and have that ready for our next video.